All right, welcome everybody. Today we're going to be doing some more IFR uh, knowledge test prep. Okay, so we're going to be doing a bunch of these kind of long form sort of diagram questions with figures, and we're going to go through a couple of those, and at the end we'll do some rapid fire kind of rote memorization questions. Go get you ready for your knowledge test, okay? Today's theme is going to be flight instruments, okay? So flight instruments, understanding what's going on with your flight instruments. The first one's going to be, what is flight attitude? Okay, it says, hey, what's the flight attitude? Like, what is going on with your airplane? One of these is malfunction. Okay, so you're gonna do some games here, 2 versus 1, right? So before we even start any of that, I want to look at what's happening. So airspeed is kind of just, we don't know. It says it's not trending, so it's just hanging out. Okay, whatever. We got kind of a right turn happening here. See that little right turn? Okay, this is also a right turn. Airplane's going right because if the heading is becoming further to the right, see that? Because that's spinning left, right? Cutting to the right. Um, So, your heading indicator is a good one for which way you're turning. And then this, your turn coordinator is not saying you're turning at all, right? So you have two things they're saying we're turning right. One that's saying we're not. We're going to go ahead and say this is the bad one, probably, out the gate, okay? And then lastly, we want to figure out if we're going up or down or what are we doing, climb and level. So we got trending up on altimeter, trending up, see that? And then we got trending up vertical speed. That's two things they were trending up. We're going to go ahead and say we're climbing. So climbing, turning right, climbing, turning right. Easy enough. Just remember that you got to kind of figure out which is lying to you before you decide. Because this is saying level, you might say, oh, level, whatever, like level. Okay, I'll do that one. No, it's not level. And you're not in a left turn, you're in a right turn. These are easy to mix up. You see this like, I'm turning left. If you see this, don't let this trip you up on the test, okay? Don't let this trip you up. This is a right turn. Heading indicator sliding left means the airplane is turning right. All right, on to the next one.
So, identify the system that has failed and determine a corrective action to return the airplane to straight level flight. So this is kind of the same thing as we did before, but now we're going to actually do something about it. The FAA says, I know you know which one, now do something about it. So here we go. So there's kind of a couple things going on here. Your one thing to note is your answers are it's either going to be the pitot-static system, vacuum system, or electrical, right? So keep in mind which these affect. So pitot-static, right? Like your pitot and static for your altimeter and your pitot and static for your airspeed. So if something's wrong, it's going to be one of those two. If something's wrong with this, vacuum, obviously your attitude, and then electrical, your electrical systems, right? So if you have, um, if you keep that in mind as you're going through this process of elimination, that'll help you out. Okay. So let's look at our trends. Okay. Let's look at our trends. We're going to start with the airspeed. Airspeed is trending up, meaning faster, right? So what does that mean to our attitude? It usually means we're like, nosing down to speed up, right? Nosing down to speed up means losing altitude. This says we're climbing. Attitude says we're climbing, right? So we got climb in there. So those two already disagree. Okay. And then we'll break the tie here with the altimeter. Altimeter is saying rolling this way. If your altimeter's rolling this way, right? What's that mean? It means you're going up in altitude, meaning you're climbing. So we got climbing versus descending, probably. So I would say that out the gate, I'm suspicious of old boy here. Airspeed. I'm suspicious. Like, hey, maybe this is messed up. If I was flying this airplane, I'd be like, it's probably that's what's going on. Now I'm gonna go for even one more knockout punch here for airspeed, which is vertical speed also thinks we're climbing. So now I got four. Do this. Sorry, 3 versus 1. So I'm thinking airspeed's busted here, right? So you could just stop right now and go, okay, which of these says pitot-static system? A, because we know pitot-static and airspeed are related, right? We know those two things are related. That's how it gets its info. So I'm probably thinking right now, I'm going to click A. I'm clicking next question on my test, and I'm going to go on to pass, right? Easy money. But we can talk about it a little bit more just in case you don't get these questions. So we talked about the trend in altitude. Let's talk about the trend in turns here, okay? So we'll do turns. So remember this one. We saw this one before. If your heading is saying, I'm spinning left, it means your airplane's actually turning right. So this is telling you right turn. Attitude's telling you right turn. So now we're at 2 right turns, okay? Turn coordinator is saying a right turn. Okay, does anything disagree here? No. All the 3 things can tell you turn are saying turn. So it's probably not like maybe your vacuum or one of your like. I mean, none of that is giving you any problems, right? The way we got with the pitot-static. So sometimes all 3 are going to agree, and that's fine. We already determined earlier that the answer was here, but it's just good to talk about. Okay. All right. I think when it comes to the six-pack instruments here with something failing, identify the system, I think we got those. We can move on to the next section. Next up, we got turn and slip indicators. So we're going to figure out, these next two questions are both going to be using figure 144. So figure 144 is going to give you 3 turn slips, okay? The question is, which illustration is indicative of a skidding turn? So remember when you're skidding, if you're turning, like let's say I'm in a left turn, then the ball will be deflected to the right, okay, if I'm skidding. And if I'm in a right turn, the ball will be deflected to the left, okay? So what's that look like? In this case, all 3 of these are saying we're in a left turn, right? You see how they're all 3 pointed to the left? Left, left, left. It means we're in a left turn. So we said skidding turn is opposite, skidding opposite, right? Skidding opposite. So left turn, right ball deflection. You're skidding in number 1. For what it's worth, left turn, left, that's a slip. Left turn, nice and coordinated here. That's neither a slip nor a skid. And also for what it's worth, this is probably what you're trying to go for, right? Unless you're intentionally slipping. You don't really want to be skidding, so like this is like good, do this in flying. But for this question, won't get off track here. Skid, all to the right. So the answer here is just gonna be number 1. Okay, number 1. Number 1 is A, right? Now, the way you're gonna miss this, if you understand this, is you're gonna do what I think I see people do sometimes, which is, let's say A is 2, you know, B is 3, and C is 1, right? So the answer would be C1. What happens is you go 1 and you just click the first one. So don't do that. Just look at the number 1 and try to make sure that they match. It might not be. I just made this, so it might not be like that on the test. Okay, so just keep that in the back of your mind. And we'll go on to the next one, which is going to be what changes in control displacement should be made so that one result in coordinated standard rate turn. So again, it's first one is like, hey, understand what's going on here, and the second one's like, what are you going to do about it, right? So in this case, we're going to figure out what control displacement should be made. So that 1, which again, we're going to use 1 here, should, let's get rid of these we don't need those, in a coordinated standard rate turn, okay? So we talked about it before, but we'll do it again. You're in a left turn, right? Because this is straight, this is left. You're in a left turn, and the ball's deflected out to the right. So you're skating, right? We talked about it earlier. What do? Step on the ball. Step on the ball. So the ball's on the right. You're going to use your right rudder. So in this case, it's going to be one of these 2 questions, or these 2 answers. It's going to be right, and we can eliminate C. See you later. All right. Now, the second part is, since we got a 4-minute turn here, and in order for it to be a 4-minute turn, kind of what that's saying here is like, if this little needle, see this little needle here, if it was pointed directly at this like home plate looking house guy, then you'd be in a standard rate turn, right? So we're not pointed to that. Get rid of that stuff. We're not pointed to that. So we're less than standard rate. So we talked about step on the ball, press the right rudder. So we know it's one of these 2, and then we're actually going to increase our rate of turn, because if we increase our rate of turn, then we're going to get this needle from going to here. It's going to make its way over here. If we increase it, then you'll be doing doghouse here, which is standard rate 4-minute turn. A little bit of right rudder, get that ball coordinated, and you'll be on your way. So we're talking about this answer right here. Increase right rudder, increase rate of turn. Okay. If you want to coordinate this turn over here, you want to press on the left ball. So step on the ball, so press on the left rudder, and you're already coordinated here. So that's kind of the examples. All right, moving on. All right, our last couple questions here. We're going to do 2 standard rate turn questions and then 2 compass error questions, okay, for flight instruments. So first, standard rate turn. So before we get into any of this, we need to know what this is, standard rate turn. So a standard rate turn is determined by going 360 degrees, okay, in 2 minutes, okay? So you're going to mess this question up. If you're going to mess it up, you're going to mess it up in one of 2 ways. You're going to click B and you're going to go on. Now you got it wrong. So that's the number 1 way. The number 2 way is you're going to click A and move on, right? Because there's reasons why you might do that. So you might not really read this all the way, and you might accidentally click 360 and 2, which would be, you don't want to do that. It's actually a half standard rate here. So if you're going to go half standard rate, you might take 2 minutes. This is the other way you're going to mess it up, and go half of that's 1 minute. Okay, 1, A, next, boom. No, don't do that either. If you're going half standard rate, it's going to take you twice as long. So the answer to this question is actually 4 minutes. Half standard rate, 360 is 4 minutes. So those are kind of the two ways you'd mess that up. So don't do that on the test, okay? Now, the other way you can think about standard rate turn is if you're going to go 360 degrees in 2 minutes, that means you're going 3 degrees per second. Okay, 3 degrees per second. If you're going 3 degrees per second, how long would it take you to go 135 degrees? Well, you do some math. 135 divided by 40 divided by 3 equals 45 seconds. So do you see 45 seconds here? Yeah, me neither. It's because, again, this is the other way you're going to mess it up. Remember, we talked about half, right? These both have it. These both have that half right there. So be careful. Half means it's going to take you twice as long. Twice as long of 45 seconds. 90 seconds, also known as 1 minute, 30 seconds, okay? So that's going to be your correct answer now. 1 minute, 30 seconds with some quick maths. Easy. All right, on what headings will the magnetic compass read the most accurately during a 360-degree level turn while also banking? So the key here is banking, because compass errors are turning errors, right? So if you're turning, your magnetic compass wants to be doing good stuff, but when you're near the poles, so when you're pointed, not near the poles, sorry, but when your heading is north-ish or south-ish, you're going to get some turning errors, okay? So we're trying to be accurate with this. So when will it be the most accurate if northern and southern headings give you errors? Well, how about easterly or westerly headings? Boom, right? So if you're turning, and you're going to want the most accurate reading while turning, you want to be looking, east or west, okay? So that's the answer to this. So again, this wouldn't make any sense because that's where the turning errors are, 180 and 0. So see you later. And then 135, that it wouldn't be as bad as 180 and 0, but it wouldn't be as good as 90 and 275s, right? We want most accurate, so this isn't the most accurate. It would be most accurate be there, furthest from the headings of north and south, right? All right. More magnetic compass errors, right? So we talked about it a little bit, but now let's see how they work. So when you're initiating a left turn in the northern hemisphere from -270, 270, the magnetic compass will do what? So if you're going 270, it's kind of counterintuitive here because this question is talking about magnetic compass errors, but you're on heading 270. We just talked about it. It's most accurate. So what's it going to do here at 270? Probably. Is it going to do some lag behind stuff? No. Is it going to do initially indicate turn this way and then flip it? No. Why not? Well, none of that is happening over here at 270. It's probably going to just do what it's supposed to do, which is initially indicate the actual rate of turn. So it's kind of counterintuitive, I know, but on this one, you got to look out for that. It's compass errors. It's actually going to be, the answer is no error. Okay. So good rapid fire, good questions from before. I'm hoping that you guys learned something from this today, and I'm going to keep making some more of these IFR knowledge test questions. I wish you the best of luck on your test, and thank you so much for watching. See ya.